What is basically slab? Slab means basically the width is more than the thickness, then we call it a slab. So, width can be say about 1 meter and more than a meter, maybe 1500 millimeter, that means 1.5 meter, it can be 1 meter, and the thickness may be only 200 millimeter, 150 millimeter. So, width is much more. This is the width and this is the thickness. If the width is more than the thickness, we call it a slab. So, this is the longitudinal direction, Z is the longitudinal direction, Y is the width direction, and there is a thickness direction X. So, now let us see what are the cracks, surface cracks on cast slab. That means cracks will be visible on the surface of the slab itself, that is why they are called surface cracks. So, one is the longitudinal mid face crack, this is the one, this is around the middle area of the surface, broad surface. This is called the narrow surface, this is a small surface, this is a broad surface. You may have a crack in the mid surface of the narrow surface also, but relatively incidence is more on the broad surface, that is why we have shown it on the broad surface. So, it is a longitudinal mid face crack on the broad face. Now, 2, again it is not in the mid face region, any other region, but direction is longitudinal, so we call it simply longitudinal surface crack. Now, what is 3? This is a corner. So, if the crack formation has taken place at the corner and the direction is longitudinal along the casting direction, so we call it longitudinal corner crack. So, now look at the location this 4. This was mid face, this was any direct any location, 3 was at the corner, 4 is we call it off corner. Why off corner? Slightly away from the corner. So, off from the corner, so it is called off corner, but it is off corner surface crack, but longitudinal direction. So, longitudinal off corner crack on the surface. So, this is this one. Now, let us come to the transverse cracks. Look at these cracks. These are on the surface, but at transverse directions, perpendicular to the longitudinal direction. So, we call them transverse surface crack because they are on the surface. Now, look at these cracks at the corner, but in transverse directions. These are, we call them transverse surface crack, but here these are again transverse direction, but location is corner. So, the 6. So, we call them transverse corner crack. Look at this crack, look at this crack, look at these cracks. These are transverse corner cracks, and these were transverse cracks at the surface. This is also surface, but at the corner. Now, look at the other types of cracks. I have mentioned, like in billet and bloom and rounds also, you can have some fine cracks not having any particular orientation, neither longitudinal nor transverse. So, we call them fine cracks. Sometimes you may call them spider cracks also if they are small and oriented in different directions. So, like billet, bloom and rounds, in slab also you can have lot of surface cracks. So, depending on their orientation, they can be longitudinal, they can be transverse, they can be at the corner, they can be at mid face region, they can be at the off corner region, and they can be fine cracks not having any particular orientation, neither longitudinal nor transverse. So, now let us come to internal cracks in cast slab. I have talked about the surface cracks in cast slab. Now, let us come to internal cracks in cast slab. This is the width of the slab, this is the thickness, this is the length of the slab. So, we have to look at the interface, we have to look at the cross section. You cannot see slabs on the surface. So, this is one section, this is another section. There is a section of the internal crack means you have to see at the section. So, this section, cross section, let us see what are the cracks. This location you will find it is not at the corner, it is off corner. So, we call it longitudinal off corner. We are seeing only the trace. If we cut another section here, you see that surface cross section, we will see the trace somewhere there. So, that is why it is a longitudinal. The crack is along this direction, but at the internal location. So, we call it longitudinal off corner crack. Now, if you have a crack and this near the corner, if you have a trace, then it would have been corner crack, internal crack, longitudinal corner crack. 2 is basically longitudinal off corner crack. I have not shown 1 because I had shown it earlier. So, that is near the corner. If it is a longitudinal crack somewhere here, then we can call it a corner, longitudinal corner crack. Now, then we can have a transverse crack near surface. So, these 3 locations, this near the surface, but not exactly surface, subsurface, slightly internal locations. So, maybe we can call it a subsurface or near surface. So, these are transverse because directions are perpendicular to the longitudinal direction. So, transverse, these 3. Here again you have transverse cracks, but near the center. This was near the surface, near the center, and these are near the surface. So, depending on the location you are giving some nomenclature, and the generation of the cracks also it will be helpful to understand how the cracks are formed if you know whether it is transverse or is longitudinal, at what was the location, that is at what stage they are formed, whether it was during casting stage, solidification stage, or after solidification. Again, when the shell is going through the transverse region, there might be crack formation because those are brittle region. So, there is a possibility of crack formation there also. Okay. So, now let us look at center line crack or segregation. This one, you have taken a section and looking at the center. So, you may have cracks, you may have lot of segregation. So, I am telling them center line crack or segregation. Sometimes they are combined together, sometimes separately you can have crack, you may not have crack, but segregation is normally present always. Crack you will have if you have a relatively bad casting, then you have relatively coarse cast structure. So, your superheat was high. So, your this thing columnar zone is extending from the surface to the center, then you have crack, you have lot of segregation, is a bad central area. So, superheat plays a big role here. Superheat, that is why it has to be low to avoid high intensity of crack and segregation formation at the center line. Now, we might have, what is the triple point area? Triple point is you have the center and you have a diagonal. So, when the diagonal is meeting the central, this is called the triple point. Triple point means solidification front, one solidification front is generating from here moving to the center, another solidification from this surface moving towards here, from the bottom also another solidification front is moving towards the center. So, all the 3 fronts, solidification fronts, are meeting at the triple point. So, this triple point, like the central, like the diagonal, is a relatively high defect area. This area is prone to have lot of defects because all the solidification fronts are meeting. Like grain boundary normally is having more defect compared to the grain interior. So, here also this diagonal, the central area and the triple point area, you have more defects compared to the normal area of the casting. So, these areas relatively are weak because of lot of defects are there. So, the possibility of crack formation are also more. So, this is called triple point crack, crack at the triple point. So, you can have crack at the triple point, you can have crack at the central line. If had there been a crack in this direction, that I had shown it for the internal crack for billet or bloom. So, it is a diagonal crack. So, depending on the location, if it is at the diagonal location, it is a diagonal crack. If it is the center line, we call it a center line crack. If it is at the triple point, we call it a triple point crack. If the location is near the corner, not exactly at the corners, slightly off from the corner, we call it off corner longitudinal crack. If you have crack at the corner itself, then we call it longitudinal corner crack. If it is on the surface, it is on the surface crack. If it is interior somewhere here, but at the interior at the subsurface location, then we call it corner longitudinal crack internal location. So, these are the locations where you can have internal crack. These are the cracks which we see on the surface itself, again depending on the orientation. It can be longitudinal, it can be transverse, it can be fine cracks where there is no orientation, very small, and if it is at the corner, we call it corner crack. If it is off from the corner, we call it this 4, we call it off corner crack, but because of the orientation of the longitudinal direction, we call it longitudinal off corner crack. We may have mid face crack at the mid region of the surface, mid face crack. We may have normal surface cracks at any location, not exactly at the mid, not at the corner, but any location we call it normal, but the orientation is longitudinal, so longitudinal surface crack. We may have transverse crack, surface crack. We may have transverse corner crack at the corner location. These are normal surface cracks, these are normal corner cracks. So, depending on what is their orientation, what is their location, we can give different name to the cracks. This I had mentioned in this transparency, that location and direction of cracks is very important. Surface cracks, they basically related to uneven shell growth. I have shown lot of surface cracks, transverse or longitudinal, both on slab surface as well as on billet, bloom or round. So, those surface cracks are basically forming due to uneven shell growth. It can be at longitudinal direction, it can be transverse direction, the location can be mid face, near corner, so all sorts of locations can be there. So, they are mainly coinciding with longitudinal depression. Not always, sometimes you can find cracks, but not depression. If the casting condition is not good, if there is a sudden fluctuation in casting speed, sudden fluctuation in heat transfer due to some reason, you might get crack, but you may not get depression. So, but normally what is found is if you have longitudinal depression, you will always find some cracks either along the depression or at internal cracks interior to the just beneath the depression, that is below the depression. So, surface cracks can be longitudinal at mid face, near corner, I have shown different directions and locations. And then we can have transverse cracks, normally related to deep oscillation marks. I have mentioned oscillation marks are in transverse direction. If the oscillation marks are deep, then it is a real defect. If their oscillation marks are shallow, it is not called a defect, because what is going to happen to that cast product? If you have shallow oscillation marks, any shallow defect, because this will be heated, normally put in the reheating furnaces before rolling. So, in the during reheating there is a formation of scale, and so for very shallow surface defects, whether depression or crack, if this is really shallow, not very deep, they will be going along with the scale. But if you have a deep oscillation mark, if you have a deep crack, if you have a deep depression, whether transverse or longitudinal, they will not go along with the scale. So, during rolling also they will remain and they will generate lot of defects. So, what is important is to avoid deep oscillation marks. These you can avoid, as I mentioned, by controlling the oscillation parameters, by controlling the negative strip time. So, it is possible to control deep oscillation marks, because normally if you have deep oscillation marks you can have transverse depression and transverse cracks, and also if you have transverse depressions you can have transverse cracks. So, you have to take care of this. Now, I have mentioned that for internal cracks you may have a lot of internal cracks I have shown. So, they are related to interdendritic hot tears. I mentioned internal cracks at different locations, at corner locations, at central location, at triple point location, at subsurface locations, along corner or off corner. So, they are interdendritic hot tears. That means at intercolumnar or interdendritic locations where the strength is low, the ductility is low, those areas their crack formation is more probable. There is high possibility of formation of cracks on those areas. So, interdendritic hot tears caused by strain in solidifying shell. So, whenever the strain is exceeding the limit, you will have crack formation interdendritic areas. So, we call it hot tears. I have shown it can be at midway, it can be diagonal, it can be triple point, it can be central line. So, the possibilities of crack formation are there at different locations at the surface, internal. I have tried to tell you what are the possible reasons surface cracks related to uneven shell growth. So, the heat transfer in the mold surface cracks normally you find either at the initial stage of solidification, or it might also form if you have a lot of uneven surface in chemistry like 0.1% carbon. That means if the surface is uneven, lot of depression is there, so grain sizes are coarse. So, if the grain sizes are coarse, grain boundary areas are relatively less. So, even at low temperature, that means around 600 to 700, there is a possibility of formation of nitrides of aluminum, niobium, So, those will try to form at the relatively less ground boundary area. So, the density of the precipitates will be more if you have coarse grain. So, there is a possibility of crack formation because of that. So, on the surface cracks can form due to two reasons, because of uneven shell growth, or if the surface is having coarse grain, coarse structure, then at the brittle temperature, at the low temperature brittle zone, which is around 600 to 700, this uneven shell growth is happening at high temperature during the stage of solidification. But the low temperature brittle zone, which is around 600 to 700, there cracks might form because of the nitride formation of aluminum, niobium or vanadium. So, there coarse grains is the problem. So, we have to control the heat transfer in such a way in the mold, so that we do not have too much of depression, we do not have too much of surface roughness. If we do not have surface roughness, then we do not have coarse grains. So, we do not have this low temperature brittle zone will not be there, because the nitrides will be forming along the grain boundaries of the finer grains, which is a quite large area. So, the density of formation of the nitrides will be less, and the brittleness also will be relatively less. So, the reasons for surface crack formation are twofold. One is uneven shell growth from there, either during solidification or during at low temperature in the solid state itself, there can be crack formation. But internal cracks, they are basically interdendritic, that means they are basically hot tears. They can form in different type of chemistries. If the structure is coarse, if it is the columnar zone is more due to high superheat, then you can have these hot tears. So, if the structure is coarse in the interdendritic areas, there is a possibility of hot tears, and the strain is exceeding the critical limit, then these areas, interdendritic areas, are prone to formation of crack, which may form at different regions, midway, diagonal, as I have shown it here. It can form at the central region, it can form at the diagonal, it can form at the triple point, it can form at different locations off corner, it can form at corner. These are weak areas. So, there is a possibility of formation of those internal cracks because of hot spot formation, because of tear interdendritic region which are relatively poor in strength. In the slab also I have shown, you see, these areas, either central or the triple point areas, or at the corner or off corner, even at the mid locations, transverse crack either near center or near surface. It depends at which area of the casting after solidification. If these areas are just solidification is complete, suppose solidification is complete at this area, so there is a formation. If there is too much of strain, that area is going to generate crack. When solidification has gone ahead, so even the central region, because of the coarseness of the structure, you can have crack. You can have crack at the diagonal area, you can have crack at the triple points, again because of coarseness of the structures. So, these are called internal cracks at different locations, either triple point, center, it can be longitudinal, depends on the orientation. Why longitudinal crack will form and why transverse crack will form. Try to understand the reason for that. Longitudinal crack will form. Let us go to the surface, then it will be better to understand. Longitudinal crack will form when there is a transverse stress during casting or during cooling. If the stress is transverse, you have longitudinal crack. Transverse stress means stress is occurring in this direction, there is a possibility of longitudinal crack formation. But if you have a longitudinal strain or stress, then you have a transverse crack. So, depends on the strain direction. Strain can be during solidification, you can, as I mentioned, you can have strain at different point of casting at the different point of the caster, different location of the caster. You can have, due to bending, there can be mechanical strain. Then there is a shrinkage. The direction is something, in shrinkage direction will be away from the cast front. So, it is towards the cast front, that means it is transverse in nature. So, if the stress is transverse in nature, you may have a longitudinal crack. That is why what I am mentioning is the possibility of having longitudinal crack is there when the casting is just taking place in the mold, because these have formed mostly in the mold area. Either in the mold, there will be initial stage of solidification, or as I mentioned, for certain chemistry you have very coarse structure. So, because of the coarse structure, the cast grains are coarse, the grain boundary areas are less. So, at temperature of 600 and 700, that means when you are cooling it, there is a possibility, if you cannot avoid that particular area, if you pass that area, that temperature area in a relatively, it takes long time for the shell to be in that brittle temperature zone of 600 to 700, you may have generate cracks because of the formation of nitrides. So, coarse grain is the culprit there. Here the culprit is formation of tendency for the formation of depression, or tendency for the formation of shrinkage. More the shrinkage, more will the possibility of formation of such cracks, surface cracks. But if you have a longitudinal direction of tension, then you might have transverse crack. You might have transverse crack at the region of deep oscillation marks. You may have transverse crack in the region of transverse depression. So, everything is depending on what is the direction of the strain. So, the direction of the strain, if it is transverse, it will generate longitudinal crack. If the direction of the strain is longitudinal, it will generate transverse crack. So, I have tried to cover what are the possible reasons of crack formation at the surface as well as the interior. So, internal crack formation and surface crack formation. There are two broad categories of solidification characteristics, either it is prone to sticking or bulging, that is one type of characteristics. Another is it is prone to depression formation. So, if you have sticking tendency or bulging tendency, you have to tackle it in a particular way during casting. If it is if the grade is prone to surface roughness, prone to surface defects, surface roughness, that means surface depression, whether it is longitudinal or transverse, does not matter. If you have surface depression, prone to depression, that means lot of depressions might form at different locations, different orientations. So, you have to tackle it in a different way. You have to tackle it in the mold by having uniform cooling throughout the periphery of the mold. So, there heat transfer is the main issue. You should have uniform heat transfer in such grades, peritectic grades, where the carbon is around 0.1, or in 304 stainless steel, where the nickel equivalent by chromium equivalent is around 0.55. So, those areas you have to be, those chemistries, those grades you have to be careful. Heat transfer should be uniform. How do you do that? You should have proper characteristic casting powder. After melting, you should control the heat transfer in such a way that the formation of surface defects are less. So, two broad types of defects, rather two broad types of characteristics of solidification, either it is sticking in the mold or depression in the mold. If it is sticking, we have to tackle it by controlling the friction between the mold surface and the solid shell, and if it is depression formation, we have to tackle it through heat transfer inside the mold by using suitable characteristics of the powder, so that the slag, mold slag, can control uniform heat transfer, can have uniform heat transfer, can impart uniform heat transfer in the mold. So, depending on the characteristics, you have to choose the casting parameters. What should be the oscillation parameters? Again depends on what type of chemistry you are using. What should be the secondary cooling intensity or distribution of cooling in the secondary cooling area? It depends again on the type of grades. Grades which are prone to have more internal cracks, that means where the relative relative strength of the shell is less, that means I am talking of very low carbon, either delta ferrite, or very high carbon where you have austenite but thin shell. So there the formation of possibility of formation of crack because of the less strength of the shell, poor strength of the shell, either because of the characteristic which is delta, or if it is very thin, then also how to tackle it. That is very important. You should have more intensity of solidification, more intensity of secondary cooling is required in such grades. So these issues are important, and based on the intrinsic solidification characteristic of, I have mentioned of the two types, either depression type or sticking type. These are intrinsic characteristics based on the chemistry of the grade. So based on these intrinsic characteristics, we have to design the casting parameters so that these are taken care of to a large extent. These problems are taken care of to a large extent. Thank you very much.